first interest in this research came actually to explore something different from my own research field. And something that we see on the news all the time is the volume of waste that is being generated in the planet. We see waste thrown away in our seas, and we see wildlife being suffering from that. And I thought about doing something about it. And because my research area is building information modeling, I thought, why not to explore the potential of building information modeling and the management of waste. There's huge amount of unfulfilled potential related to BIM for facilities management. So most of the literature today looks into how building information modeling facilities management is applied to what we call CapEx. CapEx projects is basically construction projects, investment in new buildings within a site. A lot less is invested on OPEX, which is operations. So that makes an ideal scenario for investigating BIM and waste management. So if you look into the data in terms of environmental data, we know that the huge volumes of waste is thrown away in landfills, right? To a point that in the UK in particular, we were almost running out of space for landfills. So, and these volumes of waste are generated in cities, right? And the main idea was to explore the university campus as a mini city, a living lab where you could try to understand the flows of waste and then trying to map that so that we could create some intervention. So if you think 99% of the products that we use, they are disposed within 6 months, right? That is not sustainable. And if you think that when the waste arrives on the landfill, that 60% of it generates CO2 and 40% methane. And methane is 25 times stronger than CO2. So we have more than enough reasons to be concerned about it and try to do something. So in terms of the University of Bath campus, so it's a medium-sized university. We have around 118 buildings. And these buildings, they have different functions, such as classrooms. We have accommodation, we have catering, we have labs, we have healthcare. So it makes a mini city and an ideal scenario to explore waste management. So we have approximately 20,000 students on campus, and we also generate 280 tons of waste. We thought about doing this project in two ways. One was to improve the waste collection efficiency, right? So that would be directly savings for the facilities management team of the university. But also trying to find out the hotspots of waste within the campus where would be ideal to create interventions, so to reduce the volume of waste that is generated. We looked into the literature, and there are four main areas that we found that provide some guidance. So one is about the management of the physical waste. We looked in terms of social behavior and generation of waste. We looked in terms of management practice for the management of waste. More recent literature focused on the circular economy and how to reuse things that are wasted. From the building information modeling side, basically we had to model flows. We had to understand the flows of people around the campus. We need to understand the flows of waste, meaning how much waste is generated and where. We had to map the flows of services, how it is collected and when. And then we had to understand the geometry. So where are the buildings, how big they are, and where the waste is located, the waste bins are located. So the initial point of information that we're trying to look at was the existing information protocols within the campus. So obviously there are projects being built as we speak, and so we looked for the employer's information requirement. And what we found was surprising. So there's very little information about operations management, but also there were bias within the protocols. Right? Since BIM started being developed, right, so it has been led by design firms and construction firms. So, and there's less participation of the FM side. So, and this bias is quite visible within the protocols. We also looked in terms of literacy. And while we were speaking to facilities managers, so we could see there is very little understanding about what building information modeling is. But also when talking to designers and contractors, there was very little understanding in terms of how facilities management is conducted in such a complex site such as the university. So then we start mapping in terms of the university how much waste is generated, where it is located. A huge amount of waste, 280 tons per year. So, and also we had access to the costs of treating waste, collecting waste and disposing it in landfills. So we decided to start with the pilot. That was the university library building. So the reason why is a building that is occupied by all the students of the university in different times of the day. So we decided to pick up level 3, where because it has a larger concentration of students within that level of the building for a longer period of times. This is where students stay when they are studying on a daily basis or preparing for their exams. We used a space syntax analysis tool to identify where are the hidden spots, because we learned from social behavior that if we displace a bin in an area that's quite visible, people will use more. But if you put in a hidden area, it's very likely that people will not dispose waste in the area and will take with it. So in terms of the management of the library, that would be an ideal scenario. Also, we use the connection between mobile phones with the wireless systems to identify how many people there were in the building, which floor they were, and for how long they stayed in that space. The data is not very accurate in the sense that you know who is there. We don't know, and we don't need to know. We just had a very good idea of how many people were per floor, per area, per hour. And then we could map that in relation to the flow of waste in terms of how much waste was generated in that area. We also have used crowdsourcing software to identify how people were getting in and out of the library, also identifying the routes that they were most likely to take in accessing the building. We found a stronger correlation, and that is obvious that the volume of waste increases as there are more people in the building. Okay? But then again, we have evidence of where these places are within the facility. So then we map the flow of service. So in the library building, collection is done twice a day. One at 5 a.m. in the morning, and the other one at 1 p.m. Basically, the porter walks around, going through every bin in the building and collects the waste into it. So we questioned whether that would be the most efficient approach, considering that some of the bins, they were not even 20% filled with waste. And then we decided to simulate by changing that to collection once a day for the bins that were in areas that were quite visible to people, and therefore they were getting full, and also once a day for the bins that had less than 50%. Obviously, we take in consideration what kind of waste is being displaced, right? General waste cannot stay on site for more than 2 days because that generates smells. So we took that into consideration. Therefore, we maintained the collection once a day at least. So in terms of geometry, we generated a Revit model of the building, and that was essential for us to be able to map the path that was taken by the porter within the building. We used an algorithm that is basically the delivery man algorithm reversed. Right? The collection of waste is the reverse process of a delivery man delivering parcels. So by using the reverse of the delivery man algorithm, we could map out the time used by the porter to complete the waste collection. Obviously, there are certain areas where you have open spaces that it becomes slightly more complicated to apply this algorithm. For that, we used a Voronoi algorithm to divide the space so that we could locate each bin within a particular area that was symmetric. So the distances are maintained equal in terms of the approach that the porter takes for collection. We measured manually how fast waste was increasing within the bins. So we had a simple ruler at the time, and we took measurements at various times of the day. So then we could correlate the time between the amount of people arriving at the building and how fast waste was increasing. So with all this information together, we could simulate both the collection as it is done and the collection as if it is to be improved. So what we found was a staggering figure that in just one floor, if you optimize the collection, you save per year 128 hours. So if you multiply by 5, so that is equivalent to 8 days of work being paid unnecessarily. If you apply that to 118 buildings, right, so we have 9,500 working days. But obviously the mathematics is not so simple, right? The library has a particular type of profile of students going in and using the building in particular times. So we had to explore these issues further to get a more accurate number in terms of how much can be saved. So then we started the phase 2 of the project. So we needed more accuracy. And for that, we decided to create a sensor that tells us how fast the volume of waste is increasing inside the bins. So this is the prototype that we developed. This sensor was put together and placed inside bins in key areas of the library building, in all floors. So basically it is composed of an infrared sensor that sends signals to the bottom of the bin. So, and as you throw paper or any waste inside the bin, the signal comes back and tells you if the volume of waste is increasing or not. This is a Nodel MC chip that captures the information from the sensor and sends it to a cloud-based storage and places the information in an Excel spreadsheet. So all this is connected to a battery that gives us 5 days worth of data collection. So 24/7. So the collection was done in 5 minutes intervals. So we know precisely when waste was being put into bins. The data that we have collected confirm what we knew, so that the volume of waste was increasing as the number of students increased within the building. However, we have a lot more precise information. And more than that, the data that was collected and stored in the cloud was linked to the Revit model. We used the software Dynamo to create a code that would tell us in a traffic light system if the bin was filled up to 20%, up to 50%, and above that. So within the 3D model, you could see the bin changing color from 20% being green to red, having more than 50%, which means automatically you generate a plan for waste collection. Or in other words, the portal would go only for the bins that are red, fulfilled with more than 50% of the waste. In relation to the interventions in terms of reducing the volume of waste that is being generated, we use what we call nudge theory to create 3 interventions to see what would impact on the students changing their behavior in terms of generating waste. The first one, we displaced flyers on the library building. The first one, we displaced flyers within the library, near the points where the waste bins were, and we monitored if there was any impact in reducing waste. We interviewed the students afterwards, and for them, they didn't even notice that. So we realized that was not the best approach. The second approach was to displace labels specifying what could be thrown away or not within the bins. Within our data collection, we found that 50% of the waste being thrown on general waste was actually recyclable, and 50% of the waste thrown away in recyclable bins were not recyclable. So by displacing labels, we were giving guidance to students on what to put their waste in the correct way. By interviewing the students, which comes from all over the country in the UK, we found out that the councils where they come from, they have different rules for what is recyclable or not, and that was a source of confusion. The students perceive that as a very good way to inform them on how to improve the recycling levels, but still that would not impact on reducing waste. Finally, the third approach was to place a screen in front of the bin, and every time a piece of paper or a small minute piece of waste was thrown away, a message would pop up telling how much waste is generated in the world every day. So that had an impact. Students realized they could have a much better approach, a much less wasteful one. Simply by preparing sandwiches at home and bringing in containers that could be reused, right, would have a huge impact on the volume of waste that is generated. So when interviewing them, they said, well, this is likely to last, but not forever. Perhaps we have to have more of this information exposed everywhere in a way that it comes alive when you generate waste. So as I said before, the library has a particular type of profile of students and a particular profile of users in general that generates waste in a particular way. So obviously, different buildings will have different waste collection systems and different patterns for waste generation. So we investigated 3 different accommodation buildings within the campus to map out these different ways of waste collection. So 3 other buildings were modeled in the same way as the library. The results were less significant if compared to the library results. Obviously, the population that occupies the library is larger than an accommodation building, but nonetheless, there were savings to be made. There were potentials to improve the way waste is generated, to reduce the volume of waste that is generated. So, in terms of general conclusions of this study, what we found is that the current amount of information that is available is not enough to help managers to manage in a meaningful way waste. All we do at the moment is to collect and dispose, right? So by expanding the volume of information that we collect, so we can actually create meaningful interventions. Internet of Things, like the sensors that we have used, is one of the things that will likely to trigger change, and it gives us the information that we need. So it's not just the environment that will benefit, but also facilities managers by having a more efficient system for waste collection. So in terms of the barrier, what we found is a university with 118 buildings, modeling the legacy, all the buildings, is the major barrier. Currently, we are modeling the whole campus, and the idea is that we're going to expand this project and place sensors everywhere and creating this system. We call it the Come-Bin system, based on the Toyota production system, where we collect in an efficient way, but also we make interventions where we can reduce the amount of waste that is generated. So during the whole development of the research, we engaged with the BRE Trust team, and we envisaged that at some point in time we will implement these ideas also in the technological village of BRE in Watford. This research was only possible because the BRE Trust, in partnership with the Worshipful Company of Constructors, created a research call, interesting in things that were different, that could make a difference. We're very thankful to the BRE Trust for establishing this partnership with us.